Good morning. Last period we started the second chapter from F.Y.B.Sc and from the paper second, that is organic chemistry. The name of second chapter is Aliphatic Hydrocarbon. And last period we already discussed about the some properties of alkane, their IUPAC nomenclature, as well as primary, secondary and tertiary alkane. Okay, and today we will see the preparation of alkane. Preparation of alkane. There are various methods for the preparation of alkane, and first method is catalytic hydrogenation of alkene. First of all, we will see the general reaction. Now here, alkene, when treated with hydrogen gas in presence of various metal catalysts like PT, PD or nickel, it gives alkane. And here addition of H2 molecule to the alkene takes place, and the reaction is carried on the surface of this metal catalyst. Now some example. This is ethene, H2 gas in presence of catalytic amount of platinum and it gives ethane. We take another one more example here. When propene is treated with hydrogen gas, passed through hydrogen gas in presence of nickel, it gives propane. This is the first method for the preparation of alkane. Then we move towards the second method. Second method is Wood's reaction. In this case, two molecules of alkyl halide is react with sodium metal is react with sodium metal. This is alkyl halide, 2 moles of alkyl halide. What happened here? Here NaX is the side product and higher alkanes are formed in presence of ether. Example: in presence of ether, this is methyl iodide and from ethane. Now suppose you take 2 moles of ethyl bromide sodium metal, this is N-butane. So this is the second method for the preparation of higher alkane. In this case, we can't prepare the methane with the help of this Woods reaction. Then third method, third method is from Grignard reagent. Is nothing but the RMgX. Now we will see general reaction. In first step, there are Grignard reagent is prepared when alkyl halide with Mg in presence of dry ether. Rx, this is alkyl halide plus Mg in dry ether gives RMgX. This is Grignard reagent. And when hydrolysis of this Grignard reagent takes place, here hydrogen from water molecule and R, here are RH is from form. This is alkane plus side product is like this, side product. Now we take some example. secondary butyl bromide. When this secondary butyl bromide is treated with magnesium in dry ether, there are Grignard reagent is prepared. Here Mg and Br. This is Grignard reagent, and when hydrolysis takes place, this is new hydrogen is come from water plus Mg, here Br and OH, and this is N-butane. Means with the help of this method we can prepare lower as well as higher alkanes. Then next one, there are total 4 methods for the preparation of alkane. Last method, that is Kolbe synthesis. Kolbe's synthesis. Kolbe synthesis is the electrochemical reaction, and hence it is called as Kolbe electrolysis reaction. And one restriction here, this method is only used for the higher alkanes. Means with the help of this method, methane can't prepare by this method. Now general reaction. Here sodium or potassium salt of carboxylic acid is used as a starting material, and when this is subjected to electrolysis, there are dissociation takes place. And RC11O carboxylate ion and sodium ion is formed. This is carboxylate ion. And when this carboxylate ion, it gives removal of electron and then removal of evaluation of carbon dioxide gas, and these two R plus combine and form the higher alkane. This is the higher alkane. Now we take one example here. Now suppose you consider the sodium salt of acetic acid. Then what happen here? Here we consider sodium salt of carboxylic acid, means sodium acetate. Then what happen? Carboxylic ion is formed here. Then carboxylic ion, one electron is removed from here, and carbocation is formed, and 2 moles of carbocation form ethane molecule. This is the method where higher alkanes are formed, but methane can't prepare by this method. So these are the some methods for the preparation of alkane. There are total 4 methods. From this, with the help of 2 methods, we can prepare the only higher alkanes, and from other 2 methods, we prepared the lower alkane also. Then reactions of alkane. Actually, alkane having the low reactivity because there are no any particular functional group, and hence these alkanes having the some reaction as compared to alkene or alkynes. Generally, this alkane show the very feasible reaction is that halogenation, and halogenation reaction takes place in presence of light or temperature 250 to 400 degrees Celsius. Due to the low reactivity of alkane, this reaction doesn't take place at room temperature, so we require light or a higher temperature, that is 250 to 400 degrees Celsius. Now we will see general reaction here. Now when we see the general reaction here, this is the symbol of alkane, X2. This is the halogen, where X equals to chlorine or bromine. When we consider the iodine here, the reactivity is very low, so the reaction takes place only with the chlorine gas or bromine gas in presence of light or 250 to 400 degrees Celsius. What happen in this case? Here this bond is break here, and X, hydrogen is replaced by X, and side product is HX. And here, actually when we consider the light here, the reaction takes place through free radical mechanism. Free radical mechanism. Now we also concentrate on this reactivity of this alkane. Here, tertiary alkane or tertiary carbon atom or tertiary proton, it shows the more reactivity as compared to secondary, as compared to primary, and very low reactivity towards the methane. So generally tertiary group means hydrogen attached to tertiary carbon atom shows the more reactivity due to the plus I effect of the CH3 group, because the CH3 group donate the electron to this carbon atom and it increase the electronegativity, and this is provide the stability to free radical, and hence here tertiary group shows the more reactivity as compared to secondary and as compared to primary. Now we take example here. Ethane, when react with Br2 either in presence of light or at light with 27 degrees Celsius, 127 degrees Celsius, and it gives CH3, CH2, Br, that is bromo ethane, and ethane when react with chlorine, light. Chlorine is more reactive. Chlorine is more reactive as compared to bromine, so there are no required of temperature, and hence it gives chloroethane. And we take one propane. Actually there are two products are formed. That is one bromopropane and this is only 3% plus 2 bromopropane to bromopropane, and it is 97%. Now why this 2 bromopropane having the higher yield? Because we already mentioned here, due to the presence of light, this reaction takes place through free radical mechanism, and hence here intermediate is free radical, and here secondary free radical is more reactive, and hence it gives the higher yield, that is 2 bromopropane. We take one more example. isobutane. We take the example isobutane. Cl2, light, 25 degrees Celsius, and again it gives two products. And here 1 chloro, 2 methyl, propane, and this is minor yield. This is 2 chloro, 2 methyl, 2 chloro, 2 methyl propane, and it having the higher yield. And there are only one reaction here for the alkane, that is halogenation. Thank you.